Okay, wait 1 minute before others will reconnect. Three persons so far. Recorded, resuming the recording, and I'll try to place those videos on YouTube. All right, so so far we have dealt with missing values. We created the diamonds 2 data set, which was filtered between between this 3 and 20, hopefully it's millimeters of y axis of the diamond, and there are other option instead of replacing 9 values is okay, but let's say that we are dealing with a smaller data set, and we just need to maintain these values because we might not use this variable. So what do I mean? Let's say that we have found those 9 diamonds which are not the same as previously, and we need to use those values to model because 9% of the data set is pretty much. And let's say that we are using caret and price. We do not use this y variable, and y variable contains very large value and really small value. What to do? If we have previously deleted those data points, we won't be able to use them. But actually, for our modeling, we do not need y. We just need caret and price. All right. So we just leave these values, and we mark each of these outlier with an a, and this NA will be placed with this function mutate. So we mutate with the if else. If y less than 3 or y equals 20, replace NA. Instead, if it is more than 3 and less than 20, then we leave the value as it is. Okay. So this is the more proper way, and as you can see, after implementing this function, we live with the same kind of values as our original data set, 53,940, and these y values are just marked with NAs. And to plot the geom point is the point plot, the how to say it, parallelogram of our values where x is x and y is y. So we will place this rectangular plot using those values to make it. So our plot plots x and y measurements, and we can see that because the round we have round diamonds, those measurements should be more or less in line. And we can see that certain points are not that good in line on the line, and that makes us understand that some of the diamonds are not great. Especially here, we have used this na.rm equals true. We can leave this expression from our, and we can see that there is the warning message. We removed 9 rows containing missing values. Okay, so data diamonds, data equal diamonds2, it contains 9 missing values. So if we haven't specified this, it won't plot. The RStudio cannot plot missing values. So it will plot the same kind of, it will produce the same kind of plot as the original one with removed, and it removes silently. It provides just a warning message. Warning message is not the error. It's okay to have this warning message. But still, in order for us to leave the warning message aboard, we need to produce an ARM. Okay, hopefully here is pretty neat. So small data set change to NA, and the large data set you can remove for because this is neglectable amount. All right, now what makes observations with missing values different from observation with recorded? For example, we have missing values in the departure time variable, so we might want to compare the scheduled and non for cancelled and non-cancelled. So here, the canceled flights are those flights where have the NA in the departure time, because no departure time missing value NA here stands in our New York flights. Others will be calculated like this. We produce the scheduled departure time and meaning the minutes, and so we here is just the timing for hours, minutes, and the departure time itself, and we produce the polygon here. Let's provide. So it's not really convenient to see what is the difference between the canceled flights and non-canceled flights, because red value is non-canceled flights and there are a huge amount of them, and canceled flights are just like the small amount, and it's good that only maybe 1-2% of flights are canceled and others are okay. So frequency polygon, it's not the best choice to just represent the difference between them, because we need to again produce the plot with the limiting values here in the count in order to combine to see what is the difference. But still, we can use this NA variable to produce another type of variable and compare them between. Okay, next, covariation. Covariation is when we have the movement of two variables together, and we can use this covariation technique later on in our, maybe Plamen will tell you about the trading between the, based on the variation and covariation, or maybe Richard will tell you about that. Really good technique, and we can see that the movement of one variable goes alongside with another variable, and if the price of the assets change, we can see that they are not moving in the same direction, and some asset might be underpriced and the other is overpriced, and we can base our trading strategy in thinking of that they have to move together and move meet somewhere in between. So here, again, we are building the frequency polygon, and let's explore how the price of a diamond varies with its quality. We can see that here's the price value, and the price value depends on the cut, and the actually you can see really interesting value here. When the price is really high, the cut does not add to the price, and we can see that even fair priced, fair cut diamonds have the same kind of pricing. This is on the y-axis there on the count, so it doesn't matter. We see this fair and good lines over here alongside with the ideal cut, and they reach the same amount in prices. So it's really interesting for us. Let's produce the geom bar, and geom bar, this is only the count, maybe we can compare them. Yeah, we can compare with them with the density. Let's produce. So the density is just the normalization. Instead of counting how many values, we just divide all by the values, and we have the relation of the frequency. Here's the density. It shows us the frequency of the values, and here it is possible to see that fair price diamonds in this price range, fair cut diamonds cost even more than the ideal cut diamonds. Uh, Maybe ideal cut diamonds are not that large, that's why they are having, but based on one variable, it's really hard to say why it is so, because cut is not the really important thing of the diamond. Maybe the clarity, maybe the size of the diamond are more important than the cut of the diamond. So let us look at the distribution. Here it's really important to place these dots before the density, because it is the function density. It is not the word density. It is the function which starts with two dots and ends with two dots. So it's really important to place it over here. And you can use help to understand what are different ways of producing some kind of the density, the internal functions inside the ggplot. Box plot. Box plot is let's say, yeah, it is the last thing I need to tell you. Here, the box plot. Maybe you can remember from the statistics class what was happening here, but each box plot contains, let's say, here is the values which falls into IQR. IQR is the interquartile range, and here is the smallest value. Here is starting the 25% of values lies below this line, and 75% values lie up this line. Here is the median value, and median value separates 50% of the values. So 50% of the values lies below here and 50% up here. And here's the third quartile, 75% values lies below here and only 25 up here. So here's the maximum value of, and here's the minimum value of three standard deviations of our data. And upper than the three standard deviations lies the outliers. So we can consider those values. These are just dots. And if we see that the outliers are higher than the price of 10,000 to the fair price diamonds, and there are more dots, they are more densely like over in these three graphs. But if we just look on what is happening inside the box, we can see that the fair price diamonds on average, they have median value higher than the very good diamonds and even the ideal price diamonds. This is really unusual, and again it just telling us that cut is not really good value to predict the price of the diamond, because so we have like illogical values over here. Ordering factor. So here the mileage across classes. Box plots are really useful for us just to understand the data set here. The empty cars data set have different classes of cars. These are those classes, and here we can see that there are only 5 dots, only 2 dots which are outliers, and 1 dot which is outlier to this side in the minivan class here. And we can compare those box plots, just really useful to compare between categorical values of what is happening. Um, based on so here is the same kind of plot, but we ordered those values. So x here is the reorder um, of our classes based on the median function. So the lower to the left hand side lies those values which have lower medians. So each these box plots have higher medians here. And if we change this median to some other function, I'm not sure, but whether it is working, because mean is not actually the function of the box plot, but maybe it will work. So the mean function works. So we can see that the sum compact class has the median, which should be over here, but still it has the higher mean value. So median and mean values are different, and we can generally see that here in the minivan class, the median value is between so with the distance from median to 75%, and the distance over here is pretty okay. It is also pretty okay here, but here it is not okay, and here especially it is not okay. So median lies lower, and the mean value is generally 50% of the distribution, the average. So this is skewed, and if we plot the distribution here on the y-axis, it will be like that. So here it will be really the same, really normal, but here it will be left skewed. So you can use box plots to just understand whether the distribution is skewed or not skewed. Okay, coordinate flip is useful when you have a longer, what to say, if you have a subcompact class of automobile of some particular value, if you have the name of the variable which is really long, it's useful to flip the coordinates to produce this value neatly, and you will be able to read them. Because in this kind of plot, it's really hard. In this kind of plot, it's really hard to read. And if you have longer names of the values, they will be intersecting, and you won't be able to see it. So to flip the coordinates, you just add this plus coordinate flip, and it will produce the plot you need. Next, we move to the two categorical variables. So two categorical variables, we are going to show how many are those values here. And we can see that there are color of the diamond, the J is not very good. It's a colorful diamond. And we can see that the not very many of those diamonds, because how big is this circle is based on the amount of actual diamonds we face. And we can see that the majority of diamonds have this G color, and these are majority of the ideal cut of these diamonds. So it's pretty neat way to get the first look, to visualize what is happening, what are the amount of diamonds based on the color. Okay, next you can see that the ideal cut diamonds are preferable, more than 3,900 diamonds, so all of this. And D color also really great, and we can see that the minorities D color of these. Oh yeah, we have 25 more rows, so there are negligible amount of different kinds. So these are the major categories, 10 major categories, and 25 minor categories showed. Okay, so this is just how we can see that the lighter the value here in this plot the majority of diamonds lie in this, and we can see that the majority lies into this kind of, maybe this kind of plot. So they are from D to I and from very good to ideal, and the minority is fair, and we can we have seen that in our dot plots. So later on, you just analyze what else we can say. You can delete several of these. Let's say you delete this geom tile and produce some kind of different way. If you need to understand what is geom tile, and maybe you need to change the uh, to change some of the values, you always can use help. And here you can see that there are geom raster, rectangular tile as we have used, and you just can experiment. Here are some examples of how to use those values. Besides that, I'm just also reminding you that there are cheat sheets, and the cheat sheet you need is this data visualization with ggplot2. So you can click here, and there are different kind of uh, graphs you can produce. Dplyr also kind of useful to, but you provided the solutions of the homework. I hope that you understand what is happening with the filtering and arranging and other things. So these are categorical variables. Okay, we can produce this kind of plots, and we can show it with the geom tiles. For continuous variables, we have to use scatter plots. The majority of our data can be understood by generating these scatter plots. So here in these scatter plots, we can see the dependency of the size of the carat and the price of the diamond, and we can see that there is some kind of the exponential relationship. The higher the carat, the more rapidly the price will go up. So pretty easy to grasp that. But you can see that there are lots and lots of just black dots, and you generally are not able to see something. And here we produce the alpha value, which is really low, 100th of alpha value. That means for only 1% of 99% of transparency will be reduced based on these dots, and you can have a pretty neat look on what is happening. And you can see there those are the dots which were fully covered. I'm just produce sorry, here it is, and you can see that those dots which were fully covered with black, now you're able to see them here uh, in this transparent way. This is the alpha option. Okay, very large data set. So here is 58,000 observations. It's not a really large data set. I was working with millions of pieces of data set, which barely fit in the memory because they are very large. Let's say that the population of the United States, and there are several thousands of values. Uh, it's not really great to produce that. So I uncommented these install hex bins. Oh, come on, we just showed that. So we can see the same kind of data, but with the understanding where is the majority of our data lies. So we can see that yes, this is the exponential relationship between the carat and the price, and also we can see that the majority of data, the count of our data, lies here in these um, lightly colored regions. So we can understand what is the carat, how many carats do we have, like 0.25, and the price, so this is the majority. And we have based on those values, we have the 1 carat prices, which are pretty large. We can see 1.5 over here. It's again, it depends on your monitor, but you always can save this picture and look inside your cell phone, which have generally better screens than the computer screens, and have the more clear look of what is happening. All right, another solution which we provided, and we are moving to our end. So here is the categorical variable. Another option is when we have one continuous variable and the text like the categorical variable, then we can use the techniques of visualizing the combination of that. So the price is the numerical variable and carat is the categorical variable, and we just provided much more the how to say um, much more beans here. So much more box plots, and we can see the how it grows. This is the exponential growth of those carrots, and we can see that diamonds with low weight, they generally don't have this much difference in price. These are only several outliers, maybe based on the really great diamonds over here. And 1 carat diamond are those which are can cost as low as this value and as high as this value. So the really great variation of pricing for here. Okay. And the last thing is patterns about the relationship, and we can see the scatter plot, the same kind of thing that we have produced with our density plots. The same kind of thing we can generally see between um, those two densities, which were like here and like here. We can see with the two clouds of points, and these clouds of points shows us uh, how many. This is the eruption time or eruption x is eruptions, y is waiting. So the how the length of the eruption itself of the geyser, and it's generally between 1 and 3 minutes, and there are different eruptions which are larger than 4 minutes. And the waiting time, if the eruption is not very long in length, it happens approximately every 55 minutes. And if the eruption is going to be longer, it happens approximately 80 minutes. So we can also can have some understanding of what is happening here, based on the pattern of the data. This kind of thing, the linear model, which we are going to cover in our econometrics class next semester, these are the models which are really useful for us to fit the lines to data. And lines are not just the linear models, these are um, linearizable models. So we can have the exponential relationship and just provide the log of the exponential, and we have the linear relationship, and that's why we are able to model this data linearly. What is happening here? Here the LM is just the linear model. Log is because we have the price which we think move exponentially away, and we linearize this dependency between the price and carats based on our log model. So we linearize the model. Okay, let's make it, and we can see the, oh, come on, show, yes. So we can see how the, what are the residuals of the model, what is the difference between those variables. This is the price and the carat, and um, uh, how the price depends on the carat, and the model fits the line, and the residual is the difference between the actual point and the line. And we can see that the line can be can have those large amount of residuals of one carat diamond because it's impossible to fit the line through these highly variance 1 carat diamonds. But 5 carat diamonds is just like that, and it's pretty easy to understand what it will happen in those 4 and 5 carat diamonds. But again, we can remember our initial um, look at the data, and we can just understand that there are not very much points, not very many points there. There are only 20 diamonds of that size. So the majority of that, the variation here is not very large, and the variation of other diamonds based on carats is really large. So based just on the carat, we cannot understand what is going to be our price. We have to place more and more variables, and we have to place the clarity, we have to place the cut, the overall size, and everything. All these variables are necessary to understand what will be the price of the diamond. And if we have produced the model which comprises not with just the log carat but other variables inside, maybe our residuals will be lower. And if we are able to change from these residuals to, let's say, these residuals, it will be much better for us to forecast, because the residual is the error of our forecast. So this kind of things we're going to deal with in our econometrics class later on. For now, it's just for you to get the idea what's happening. Last thing is understanding what is the cut and the residual, and uh, how can we use this linear relationship and the residuals which were produced with this linear relationship to understand the what is the dependency of the cut and the price. And we can see that the uh, all in all, uh, when we model this relationship, we can see that the fair cut diamonds, they have lower price than the ideal cut diamonds, and this is the goal which where we have been going for. And if we compare, I don't remember, but somewhere up when we first plotted these values, and we can see that the fair price diamonds, they have larger cost than the ideal price diamonds, which was quite odd. So here we dealt with this kind of problem. All right. These are the tasks. Not many tasks. 1, 2, 3, 4, 5. Only five. Maybe 5 to 10 lines of code totally to produce what we need. Just have separate these tasks and provide the answers in the assignment. So if you have any questions, I'm waiting for you. In about 2 3 minutes we will end, because we have a limit of 40 minutes. So if you have any questions, use chat.
I have a question,
Yeah.
Professor. For the first task, like think about a diamond and how you might decide which dimension. What do you mean by that? Like we look at the range, like the range of that,
Okay.
and
This is length, width, and depth. These are x, y, and z variables. Okay, these are dimensions. So you have to produce the distributions, and just by comparing these three distributions, understand what is the most important. Maybe the length of the diamond is the biggest one, right? Maybe the depth of the diamond is the biggest one. So you can have the generally you have uh, round diamonds, right? So these three dimensions have the same, the how to say, they have to be pretty equal. The best diamond is the really great round, but we don't have these values. We have length, width, and depth. So uh, go to the internet, look at the picture of the round diamond. It has the exact values of X, Y, and Z, and you can compare them with the distributions with the three graphs that you have produced.
So should we visualize everything via using like via like a line graph or like a diagram?
Um, we specifically follow the distribution, so it might be the frequency polygon or the distributions like here in the beginning, geom histogram. Okay, so you use those to visualize, and you provide three of them, three histograms.
Like so we need to produce 3 histograms like regarding X, Y, and Z.
Yes.
All right. Thank you, Professor.
Okay. Okay. Anything else? All right, then. If you have more questions, then just write email. Okay. Thanks all for coming. Let me. I'll try to produce the videos for as soon as possible and load it to YouTube. So if anyone loses some point, then rewatch the video. Okay. Thanks for coming. See you tomorrow for money and banking. Bye.
Bye-bye, Professor. Thank you.